So we'll go ahead and get started. For those of you that are interested, I'll do it again here in a few minutes too, just for those that we usually get a few uh, people that jump in here at the last minute or two. I've thrown in the handout for today's class. So if you want to take notes as we go through the process, you're more than welcome to. And again, like I said, I'll throw that back in the chat here in a little bit. So today we're going to kind of to walk through the concept of what are some of the testing expectations, requirements of the Commercial Energy Code. We'll hopefully have a diverse conversation. So hopefully you guys have an opportunity to ask some questions. If you have any questions throughout the process, feel free to use the chat or the Q&A function. If it's something that you think we need to talk about out loud, raise your hand. I can unmute you and you can jump into the conversation. And other than that, we'll get started. For those of you that, again, maybe new and don't know who we are the Minnesota Energy Code Support Program. We're a utility-funded outreach education program to really help get information on the current expectations of the state building energy codes to contractors, designers, inspectors, plans examiners, the entire building safety community, including some things for the, when we interact with the public even. So if you have any questions about resources that we might be able to provide or assist with, please always feel free to reach out to Hope or I or Jim or any of our team to keep us involved. Let us be a free resource for you. And again, we are statewide, so if you have any questions, feel free again to ask. One of the things that, as you know, one of my favorite questions or statements is really when we understand why we're doing something, we're better able to figure out how we accomplish it. And we start talking about why do we test? Why do we commission? Why do we use these methods of verification? It really is to do what the code is asking us to do, which is to build, to provide some basic uniform expectations about how buildings should perform. That's why we have building codes as a whole, right? To provide that level of control. I like the word C for control. And so when we think about those expectations, those goals of the building code and of the energy code, that's how we can better understand why we do the things that we do and how we do them. Now, remember that the energy code, especially when we think about it in the context of the conversation about testing and commissioning, is really looking at how do we regulate, concepts like heat loss, climate control within the building. Now, we've talked about it before. The energy code from a commercial energy code perspective addresses a variety of different types of buildings, from new construction through new additions, alterations, modifications, changes of use, new equipment. And so why do we really think about, how do we address this idea of testing? Well, I always go back to our foundational consideration, right? If we look at the energy code as a whole, how does it really get into this question of how do we administrate the code? And we see that in Section 4. Section 4 gives us a lot of information on how we're to administer the code. And one of the things that we start to see is in Section 4.25, the concept of verification, testing, and commissioning is brought up, right? We understand that it incorporates both the systems, the controls, and the envelope, right? And so when we think a lot about the energy code, I know we've brought this up, and it's one of those things that I think we are starting to see some movement in. We think of the energy code as this code that addresses insulation, right? It's the insulation code. Well, in all reality, it's more than that. It's building on the existing mechanical code and the existing the state mechanical code, not just existing buildings, but new construction. It builds on those concepts and says that those systems that are part of a building should, in theory, work the way they're designed, right? And as we'll go through some of this, and to me, it kind of starts to make sense as to why and how we incorporate the concept of energy code compliance into our normal daily roles, right? But when we think about what this says, is we have to look at both the building system, the systems, the verification testing requirements of the systems, both the commissioning requirements and those things that we have to have prior to the final CFO, prior to final occupancy. And so when we let's take a quick walk through 4.2.5. And what it tells us is that we basically have to provide that verification of functional testing to confirm that the building components, those again, systems, controls, and envelope, will perform as they're designed, right? For certain alterations and additions, we're going to again verify that those new systems are going to work effectively. I always go back to this concept that when I installed when I, as a mechanical inspector, inspect a new furnace or appliance, some piece of equipment that's been installed, I'm looking at the safe installation, right? I'm making sure that it's properly anchored, that it's properly connected to a fuel system, that it's properly wired. What I'm not looking at in that 15 to 30-minute inspection process is, does it work right? Right? I'm not checking. I don't have my anemometer out or my wind gauge out and saying, okay, what was the expected CFMs of air movement at uh, this duct? That's not what I'm there for. That's where again we come back to this concept of commissioning. When I do the inspection, for most of us, we understand that the inspector is a random, somewhat periodic inspection process. We don't watch it. We don't stand on site, at least for most projects, from foundation to final inspection. We leave. We come back and forth at different pre-appointed times to verify that systematically this building should have been built properly. It's that individual, that verification provider, that's going to be the one who's going to be on site. We think about this like special inspections, right? If we're doing some kind of a structural steel or maybe some kind of special concrete, we may be using special inspectors to provide a more thorough, continuous type of inspection. That's what I think, in my mind, most closely aligns to the expectation we see here. Now, what I do want to verify and point out is what the code says about those verification and testing providers, right? What it recognizes is those people are employees or qualified employees of the owner, right? And as we see here, those providers shall not be people that performed the design or installation, but they can be, if they're properly qualified, they could be employees of the company, right? You don't have to have a third party come in, right? Because at some point, we have to, take off our legal our legal goggles and say, what is the purpose of inspectors? Honestly, we can if we're going to go down this rabbit trail of, well, he knows the designer, he knows he's a contractor, he's an employee. Well, at some point, we could do the same thing with us as public employees, right? We all work for the same jurisdiction. We all work in the same places. We all go to the same restaurants and hotels and restaurants and different businesses. And so ultimately, what we're looking at is professionalism, right? We want to make sure that this person is qualified to do the type of assessment that's going on, and that again, they're not the one that actually installed it. It'd be one thing to say, take a game. I remember that back in high school or middle school, right? We would grade one another's paper. Did anybody else have to do that in this class? We'd do the math class, and then the teacher would say, "Hey, hand it to the person next to you, and they're going to grade your paper." Right? It didn't go through and say, "Well, hey, I know Jimmy, and so I'm going to give him all 100," because the teacher's still going to come back and say, "Okay, pass him forward, and we'll see how good of a liar you are." Right? And so ultimately, what we're looking at is, again, we want someone that's going to be not directly associated with the project, that's doing that evaluation work. And again, it's kind of one of those things. I just want to make sure we reinforce that we don't need a third party. We need somebody that's just independent and qualified to do these assessments, these evaluations. We know that from the very beginning in Section 4, that's where we get our list of expectations associated with the information provided on our construction details, right? That's where we get that list of, all the expectations that we're going to identify the provider. We're going to verify that they're going to verify that the relevant sensors, devices, controls are all in place. That kind of We got a Q&A in there. It was not military school. Thank you, Paul. Right? No one else had to do that. I always had. Mrs. Perry, Mrs. Perrin had us take a test, turn around, and say, "Give to so and so. Now hand it forward. See if you're." But anyhow, what we expect is that again we identify from the very beginning. Like I said several times throughout trainings, if you knew that there was a test at the end of this class, you would choose a different class, or you'd be prepared for it. What we don't want is that halfway through the process, somebody sends an email out that says, "Hey, did you do any of that foundation testing? Did you do the geo test, the geotechnical testing on that before you put in the foundation? Because I noticed we're on level 4 on this high rise. Did anybody test the ground? What do you mean, right? We look at that with some comedic glasses, but at the same time, those expectations of what we're seeing in the building are listed, right? And so when we look at that again, what we're trying to do is identify and you know who is going to be doing the testing, what is being tested, and how are we testing it, right? Those are expectations that should be part of our plan from the beginning, right? Now there are always going to be exceptions, right? We know, right, that there's going to be exceptions, and what the code tells us is that not only it gives us some basic understanding of some of those exceptions to building commissioning. Now remember, commissioning can follow either one of the ASHRAE IES standards or generally accepted engineering standards acceptable to the building official. So again, that's part of that. It's hard for me to accept something that's never explained or given to me at the beginning of the process, right? But when we think about things that are outside of the process, remember, we're trying to identify and think about this holistically. Not every building, not every component is going to have to go through some rigorous expectation of qualification. And so what we see here is if a building is less than 10,000 square feet of conditioned space and uses less than 960,000 BTU of heat, then or of heating, cooling, and water like as a combined quantity of energy, it's exempt. Now, does that mean that owner may not stay? I still want it tested, or that this is my thing. That was always financial institutions that would call and say, before we sign off on this $3 million addition, how are we going to make sure it actually works? That we're not just spending $100,000 on a really nice looking boiler system that's just going to be a paperweight because it doesn't work right, right? They wanted to know just as much as anybody. And so when we think about that, there are certain exceptions. And again, if something's following the simplified HVAC approach, again, we've got a simplified design. If we've got a dwelling unit, is going to be something, or if it's a non-refrigerated warehouse, again, it doesn't have any heating system. It's unconditioned space. There's nothing to test, right, in that context. And so again, we're looking at how are we verifying the equipment. We've done the safety inspection. Now, what is the expectation associated with the effective operation? Because again, if the purpose, the intent is to mitigate and control heat loss or equipment energy use, we need to know if that equipment is working at its peak efficiency. Now, what are we expecting to get back? Right, that's part of what the code gives us in 4.2.5.2.1. Try saying that 5 times real fast. Right, what it's giving us is this expectations of certain activities that should happen prior to the final. This one's prior to the permit issuance, and then we'll also see a list of expectations prior to final occupancy. What we're looking for is, again, we want a commissioning plan. We want a plan very similar when we think about, again, my brain always goes back to, this is a special inspection report, right? I need that special inspections plan. I need a commissioning plan that tells me what is the expectation and who's doing what, right? That we've both identified that who's going to be providing that level of review, that they're aware that all of these questions and answers are addressed before we get started. Again, before we start putting concrete in the ground, we want to know who's going to test the soil. Did we do a soils test? Right? Same concept here when we talk about how these systems that fall under the energy code are going to be evaluated. Generally, we see these in four different types of documents. We're going to get a commissioning plan, like we just talked about. We're going to get a design review report, which is again going to be looking at it at the overall design and saying, from a peer review or from the perspective of the code, this looks to be accurate, right? There's no, this is almost like a secondary. Our company does a lot of peer review, pre code, pre permitting plan review, right? Are we on the right path? Because we might be able to find a solution differently. So that's going to be part of that process. And then we're also going to have a preliminary and a final commissioning report at the end. Now, remember that preliminary is going to be that first run through of how are these systems working? And that may identify certain recommendations, right? That say, well, this piece of equipment isn't working as efficiently as we would like it to. Or we might want to move this distribution system over a little to give a better throw of the conditioned air, or whatever it might be. A lot of times what we as the building official are going to be getting prior to that building's occupancy is the preliminary commissioning report, right? That's what we're going to get, because now it's up to that owner to say, okay, does it work? And we've all seen this, right? In residential construction, right? Where's the punch list of things that have to be done versus things that should be done, right? We've all had that list. Well, I've got a crack here. I've got some paint here. Is this going to create an unsafe building? No. Is it something that contractually you want to address? Maybe, right? That's the difference between the preliminary and the final commissioning report. The preliminary report is going to go to the owner. We're going to either get some kind of acknowledgement, or more likely in my case, I always got a copy of that preliminary commissioning report that says, hey, the boiler works, right? I remember when I bought my house, and again, I know we're not talking residential, but when I bought my house, I tried to turn on the air conditioner, right? And guess what? They didn't wire the electrical wire to it properly. The battery had died and the entire system had been working. The control, right, for the furnace was working off of the battery. So when the battery died, guess what? I didn't have control anymore over the system. The system was still working, was capable of doing what it needed to do, but the control needed to be verified. And so I had to go and verify, and I ended up finding out that they just didn't wire it properly. There was a loose connection. And so that's why I wasn't getting direct power. So again, these are the kind of things that are going to be identified as part of that process. And before we allow people to move in with that C of O, we want to know, did we verify everything that's required by the code? And did we have some did we get a copy of the preliminary commissioning report saying that the equipment's working at a level that's adequate, right? And again, if that report comes back and says, hey, it's installed right, but it's not producing near enough air to service the building's ventilation requirements, then we can look at it and say, well, then if you don't have enough air, then we're not occupying, right? If we don't have enough heat, we're not occupying, right? We can have that conversation as building officials prior to the actual C of O, because what we don't want, and they're done that, we don't want to have someone issue a C of O, and then we got to call back and say, hey, that thing we sent you, that report that says you can move in, that was sent premature. Someone clicked send and didn't mean to, right? Never good conversation. Always gets commissioners involved, county commissioners involved. But again, when we think about what we're testing, I always go back to one of our four foundational pillars of the energy code. And that's going to be our building thermal envelope, our mechanical, our service water, and our power and lighting considerations. And so we'll take these each one and kind of, it's more than just blower door testing that we're looking for, right? When we think about that thermal envelope, we know that there are three main components that we address within that building thermal envelope: the insulation, the fenestration, and the overall air leakage. Now, everything that we've talked about, we always hear that everything begins and ends with the thermal envelope, right? And that's really because it doesn't just, it's not just the first line of defense, right? That thermal envelope resists the heat transfer, but it also is identifying or verifying how does it not only resist thermal conduction, how does it control airflow, right? If we're thinking about thermal loss, right, we've heated up the interior space for a school building to the required temperature. How long before that system has to turn back on because we have uncontrolled heat loss? because of inadequate wall insulation or because of inadequate uh, or air barrier controls, right? And so again, it's a while everything in that conversation about thermal envelopes usually starts with insulation, it's not insulation alone. It's that relationship between the insulation and the air barrier, right? And so when we start to think about that, one thing that I usually see, and I'm going to do this real quick for those of you that came in afterwards, here's a copy of the handout. For one thing that I usually see, and I get reports once in a while from people doing a commissioning report on the envelope, right? It's kind of like an oxymoron term because you don't really operate the envelope, but you do verify. It's like it's a verification report. But one of the things that gets identified in that is, where is the envelope, right? I need to know what's going to be part of the envelope in order to know how far I need to go when it comes to, maybe potentially air leakage testing, or what fenestration is part of this system and what is not, right? But it's beyond identifying the where, we identify the what, right? Are we following insulation expectations associated with the traditional prescriptive compliance of 5.5, right? Tell me it's in a table, this is what I'm putting in. Or are we going to that next level of 5.6 where we do this area weighted average, right? I'm trading off some slab on grade insulation because I'm installing more in the wall, or I'm trading off the roof because for some reason air's not going to go through there, and we're going to put more in the exterior envelope in the wall systems, or on the, however we're looking at that system, we need to understand that where is important, but also what is important. Is part of that system of testing and expectations or measuring expectations associated with the thermal envelope. We have to identify the how it gets installed, right? The code gives us in section 5.81, it gives us that list of installation expectations associated with how it's being installed. I usually use this as that example of when my son and I were talking the other day. I don't talk to hear myself speak, right? Designers don't draw because they love to, right? They draw so that when we go out to do it in the real world, when the contractor's installing it, he doesn't see this break and think, oh, well, they meant I need to not put insulation. No. We need to make sure we understand how it was installed. This is again where periodic inspections by inspectors may not be adequate to say, depending on the design criteria or on the compliance path, they may need additional special inspections or inspections and reviews by commissioning agents, again, outside of our evaluation. But if just seeing this little break and the contractor puts in a break in the insulation, that's not how it was supposed to be installed, right? And so this is one of those corrections that needs to be addressed. Because again, it's not just a question of how and identifying how, but how well, right? And so again, we've given us some different guidance, some resources on our website to help give those field guides out to different inspectors and installers. But again, it really comes down to that punch list, that inspection expectations that says, well, this is what we're expecting when we install in a narrow cavity. This is what we're expecting when we install in an access hatch or in a rooftop access stairwell, right? What are we expecting when we see an above grade or below grade wall? Those qualifications are part of that expectation that commissioning and verification testing providers should be addressing. The VT have to be provided whenever new systems are installed. Commissioning is provided. So the question is so we've got a question about, I thought I saw a hand. So we got a question about whether or not commissioning and field functional performance testing are the same and how they relate to that expectation or the exception we saw earlier. And so we'll back up here for a second. Now remember, the requirement for building commissioning is a, let's back up a little further. So verification or functional testing is a form of commissioning, right? I think, do I have the definition of commissioning in here? Thought I had it in there. I might have put it in a different slide. Hold on with me just 1 second. If I don't see it there. And so what we're doing is I'm using the term somewhat, ambivalently, but really what we're looking at is that functional performance testing is confirming that the systems, the controls, the envelope are designed and function uh, appropriately, right? And that is required for any new building, new portion of building, alteration, change of use, right? So again, if we're looking at a thermal envelope that's altered or modified or expanded, we need to have that verification process. Now, that can usually take the form of inspections, but at the same time, when we get to some of the mechanical systems later on, that new piece of equipment needs to be commissioned. And that is part of the identification of functional performance testing. We need to verify that those people, those commissioning providers, are evaluating not only the equipment but also the connections associated with controls, right? A lot of times that we may have traditional commissioning done on pieces of equipment, whereas that it really should expand beyond just the equipment into the controls as well. So hopefully that clarifies that a little bit, Alan. But if not, let me know. But yeah, so what we're looking at is if a building is under that 10,000 square feet of conditioned space, then they're not required to have unique commissioning that is, but they will have a level of functional testing, right? Just because it's on 10,000 square feet, we may not be testing the individual piece of equipment to verify that it operates, but there's going to be a level of functional testing that says when I flip the switch or when the thermostat is turned on, it activates, right? Because that's not traditionally something that we as building inspectors are going around doing, right? We verify the proper installation, but we don't go back and say, okay, now turn it on and let's see, or let's see if it activates at 68 degrees. We're not sticking around long enough. I use that example again when we get maybe into the lighting conversation from years ago when I was first started out. My inspectors would send me out to do the functional testing associated with daylight sensing parking lot lights, right? And so I would have to drive out. They would make me, as the new guy, go out and sit in the parking lot for half an hour watching to see do the parking lot lights reduce or turn off due to lack of activity, right? That eventually became or becomes, in some sense of the word, that's the functional testing identified by the code that is required prior to occupancy. So when we think about those systems, when we think about, again, the thermal envelope component of it, again, if we're expanding, we're altering, we're modifying, we're new, we're not just saying, okay, the inspection done by the inspector, maybe that is good enough. Maybe that is the level of expectation, but that's why we want it identified in those construction documents so we all have the same expectation on this particular project as to how far they're going. Maybe it's the prescriptive process where we say, okay, it's prescriptive, just install it to the code, and then the inspection works for that. But again, that's part of that understanding of how well is it installed, right? And then again, that goes beyond just the insulation and the air barrier, but also moves into the concept of fenestration, right? The proper installation of fenestration means that we're considering all these different qualifications that are identified in section 5.8, right? So when we look at the energy code, it's a little bit somewhat, once you get used to it, you're used to it, right? But we have the mandatory requirement for fenestration is that it complies with section 5.82, which is on installation. That 5.2 tells us that then it gives us a whole nother list of expectations, right? So we have to really look multiple places to find out what all is required for something like fenestration. Well, we'll talk more about fenestration next week. when we get into the plan review associated with fenestration. But again, we're expecting that there's going to be some rating system that's determined by an accredited lab, that they're going to determine the U factor using the appropriate standards, the solar heat gain, the visible transmittance, all those directives, right, on how we verify that it performs the way it's supposed to, is written in section 5.8. What we're doing as inspectors maybe is going out saying, is the right window in the right spot, right? Or maybe there is a commissioning agent, depending on our compliance path. There's somebody going out. There's a VPT, verification and testing provider, going out and saying, yeah, we double checked. They put in the right windows, right? That they were properly flashed, and we had the right air leakage U factors. Those kinds of considerations. The one that we normally think about the most when we talk about the thermal envelope and the testing expectations is air leakage, right? We understand that air leakage controls have to be installed, and they have to be evaluated through section 5.8. That includes the construction of a continuous air barrier, and we talk a lot about the loading dock doors, weather strips, weather seals, and vestibules and revolving doors. But when we really get into it, what it's telling us is that air leakage, those mandatory expectations, is that the materials being used meet the requirements of the reflective or of their specific air leakage testing expectations, right? That we're going to have certain materials that have been tested to meet the air leakage requirements. That's that list of 13 different materials that we see, right? The plywood, the OSB, the certain types of spray foams. And then we see those assemblies identified as well as those concrete, shale, masonry walls, right? What we're looking for in that, and what sometimes we get, again, depending on our compliance path, is we're going to get a report that comes back and says it was installed properly. Now, you remember, we talked about this, I think, before. The expectation, it goes beyond just those wall systems, but also goes into our fenestration. And the code says that as part of that continuous air barrier, we have two options, two sections to address testing, right? Testing and verification that we have to follow. We do whole building air leakage testing, and we have to make sure that's properly installed and designed, right? So when we talk about that whole building air leakage, we know that we do the entire building, and that we have to get to the air leakage rate not to exceed the 0.4 CFMs of per square foot, right? Of conditioned space. When we have a building that incorporates both conditioned and semi-heated spaces, we are given the option to either test them separately or test them together as a single unit. So again, whether we're doing that whole building test as, again, separately, where we're saying we're testing the heated unit versus the semi-heated space, that's different than if, again, now if this was unconditioned space, then we wouldn't be testing the unconditioned space because we don't care if it's unconditioned, right? We're not looking for the air leakage of that building. Again, what we're looking for is how much of this heated space is going to migrate in an uncontrolled manner into our semi-heated space. Now we can do it as two individual units and then normalize it and average them across the associated square footages of the two different buildings. Or we could do it as a whole test doing the same evaluation, right? Where we're going to be looking at the entire building and how does this building perform when we test it for air leakage. Now remember, we driving back to that requirement, again, this information has to be retained and submitted to the building official. Because again, what we're expecting is that we're going to have multiple layers of verification. It's one of those trust but verify kind of moments, right? That functional testing is going to be provided that says not only was it, not only the homeowner or the building owner knows it, the building owner gets it, but also the building official, because we're basing code compliance verification. We're basing certificate of occupancy on this building performing as designed in our approved construction details. But there's always exceptions to the testing methodology, right? If maybe let's say we got a big enough building, we don't want to do whole building testing. So then the code says, well, if you don't want to do whole building testing, then what will allow you to do is that partial building testing, right? When you're over 50,000 square feet of gross conditioned airspace, air floor area, then you can look at it and do it in a more compartmentalized or smaller pieces, right? Where we're looking at that testing of all of the area that's directly under the roof, right? So if we have multiple roof systems, let's say there's a multi-tiered building, then we would test multiple sections because the space is directly under all stories, all floor area directly under a roof, right? It's not just the top level, anything under a roof. And then we have anything that has an entrance or a loading dock, right? So again, we're looking at things that are used as regular access points and loading areas for the building. And then we're going to do 25% of the remaining area, right? Remember, definitions matter. And so what we're looking for is something that is normally used to gain access or exit from a building by its users, right? Now, this is one of those moments where I'm glad I don't represent any of the jurisdictions in Minnesota. But generally, what I look at is the term ordinarily used does not, in my experience, when I've had projects use this, does not include those egress doors that don't get used regularly, those emergency fire egress paths, right? And so again, if this is something that's used to generally access and exit a building, that's what I'm considering a floor that needs to be tested. Now, one of the things that the code says is, so again, we can compartmentalize, we can break down the building so we don't do a whole building test. Then we can also say, well, if our whole building test came back with a range of 0.4 to 0.6 CFMs per square foot, then we can go back in and allow them to do diagnostic testing. This is not something that I as an inspector do. This is something that the functional testing, the verification, the testing provider is going to be doing. Right? And remember, that can be a qualified person on staff. It just can't be somebody that's part of the actual installation. And so again, what they're going to be doing is they're going to be running that visual inspection. They're going to be identifying those deficiencies and then identifying, verifying that those deficiencies have been addressed. That comes back as a report to the building official saying, hey, we came close, but we double checked everything and we came back with good answers. So that, again, we can say, do I have, maybe this is again where that drywall or that insulation stops, right? So I'm having uncontrolled air leakage. Or again, am I getting thermal bridging? Am I getting a hole that's leaking air? This is another example of again, a door at in a residential restaurants section of a building. And so again, you can see the difference and the impact of air loss, not just on air leakage, but also on the residual air infiltration. And so we have almost a 20-degree change, right? And so what's that going to do to our mechanical system? It's going to cause it to overcompensate, to run too much. And then when it gets to be cold outside, then that air is going to move out through that same hole. Again, remember, if we talk about the example of a steel structure, right? If we don't have proper thermal bridging of those steel members, then again, we have uncontrolled heat, thermal bridging coming into the building, and then the air handling system is going to have to compensate for that. And was it part of that original design? Just lost. So again, this is a picture from a training that we did up north there. I think this was over Maple Grove. We're inside the space at 74 degrees, right? We're doing a training there, talking about penetrations of fixtures, and we did the quick thermal pass, and we're seeing some, it's 74 inside, it's 50 at that receptacle, because what we have again is a penetration, a electrical box that was installed in the wall, but doesn't protect against air leakage. And so again, if we've got a 25-degree change between that, what's going to start to accumulate is water, right? We're going to get condensation as 75-degree air sits against a 50-degree receptacle. And we know one thing, that water and electric generally don't play well together, right? And so these are the kind of things we want to make sure don't happen. And these are the things that, again, a little bit of air leakage, we can walk around with a thermal and say, oh wait, we've got some air leakage here. How are we going to address that? We're going to seal it. We're going to do this, and that's going to, again, same thing when we see that exit door, right? This was not a traditional normal exit door, but it is going to be something that we're going to have air movement going through it. I know we don't always talk about residential, but again, residential has similar expectations. When that door is not properly sealed, we can see the difference. We can see the impacts, right? Oh, I thought that was a separate picture. We can see that we're losing significant amount of air that are affecting how that building's mechanical system has to operate. So again, we're not just commissioning and verifying the equipment, we're commissioning and verifying the entire system, including the building thermal envelope, or the building envelope as it was called in 4.2.5. And then we're also, once in a while, I just wanted to show you the cookies at my favorite restaurant, right? Buckets of cookie mix made. Oh, I'm just telling you what. Anyhow, digression. Sometimes it's a toy. That third option, right? So we have whole building testing, and then under that we had, if it was over 50,000 square feet, we could do the compartmentalize the partials. We could do it if it came close. We could do smoke tracer or thermal imaging verification of deficiencies. Third option here is that if we have a verification program, right, that by an independent third party that comes in, verifies that the system, the design, they look at the documentation, right? They verify basically that again, we've identified the appropriate materials, right? Whether that's part of an assembly or a material based on its air leakage, that they performed periodic field inspections of the materials and the assemblies being installed to verify that they're properly installed and properly sealed, right? And then they reply back with a report, right? So again, we could have a commissioning, or I use that term lightly, a verification report, verification report of our continuous air barrier, right? So again, if we have a situation, if we're in a rural area and we don't have, again, a person or a company that does the blower door testing, we can utilize this to say, hey, we want to make sure that we've at least verified periodically more than what I as an inspector am doing, because again, I don't have the capacity to be on site. But this is one of those conversations that you have at the beginning of the process, again, so that we know from the beginning. This is not where you come in 3 months after this began to say, hey, I need to go back and look at all the walls that you did before, right? This is why it's important we identify this up front in that design process. And again, when we have that fourth option that gets identified, is going to be for when we have a group R or I occupancies. We increase or decrease increase our expectations, therefore decrease the amount of allowable air leakage. And we also change the pressure, and we allow for those group R and I occupancies to be tested. Again, very similar to what we saw in item number 2, with an unguarded blower door test for based on the number of units being identified. It's 8 units. We test them all, and we verify that, again, those units are meeting that air leakage expectation. If it's more than 8, we do 20%. So if I'm doing 300 units, I'm doing 60 tests. And the code gives us those directions on at least a unit from the top floor, a unit from the ground floor, and then the largest unit, right? A representative sample. Some of those units, and again, depending on the design, depending on the project, I've got projects where that largest unit is a 2-story unit inside a 24-unit complex, right? And so maybe there's something like that. I'm just going to say in Bemidji or up north, where you've got resort style housing, and so they want those 2-story units. We're going to be testing the largest unit to make sure that when it's tested, that it works effectively, right? What we don't want to have happen is if I live in, and this is the unguarded blower door test, so either we do the whole building or the unguarded, right? If I'm living in this unit and all my neighbors go on vacation during the winter to Florida, right, because they're not true Minnesotans, right, and I'm trying to stick it out with the rest of the Minnesotan team, I don't want to pay I should not be required based on structural design and installation. I should not be paying to heat all the surrounding units. And that's why we do the unguarded blower door test. I should have control enough control to be able to just heat, for the most part, my unit, right? Not in a guarded blower door test. We've unnaturally, in my phrasing, unnaturally pressurized the surrounding units. So you're not going to get a true and adequate representation of how well that building is when it comes to its ceiling. Now, I've got a video here. I'm going to hold it till the end on doing an actual blower door test, just in case we have time to do it at the end. But again, it's a process. This takes about 11 minutes to watch. If I don't get it on there and anybody's interested in getting that video, I'll add it to the upload that goes onto the website here at the next month, at the end of the month, which is tomorrow. So again, we've gone through this concept of whole building air leakage, right, in the testing. It also says that we have to properly install it, which means that, again, we've thought about the joints, we've thought about the different barriers that they are able to resist the appropriate types of wind pressure, stacked effect, right, that we've designed it in such a way that it's going to be code compliant. Now, I'm going to jump through because we've talked about this before in that Devil of Details air barrier system, this conversation, not in July of 24, but we've talked about this to some degree before, so we're not going to really spend a whole lot of time on it. But again, remember, we're making sure this information is clearly identified on our construction documents, that the details are there for how to deal with penetrations, joints, interconnections, those kinds of things. So that, again, we know the appropriate types of responses aren't just taping with masking tape or duct tape, that we have an actual design that resists the appropriate amount of wind pressure, right? That we have it, that it's continuous, that it's not just, it doesn't terminate unnaturally, right? That it's continuous all the way around the entire identified area, that it reaches the stack. And then again, we have these different sealing, gasketing, taping, expectations identified in those construction documents. Again, someone's out going and doing this to verify that when we say, taped or sealed, that we're getting the appropriate, if this is supposed to be taped and not just caulked or covered in some kind of a sealant, then again, we have the appropriate things identified in that design. Now, like we said, 4.2.5 says that it's more than the building envelope. It's the systems and controls that have to be tested and verified and commissioned in that commissioning process. And so when we think about what is our mechanical code doing, it's, again, designed to provide us that space conditioning ventilation through proper duct design and proper installation. Now, the same way we've talked about before, my job is not to go out and rerun all the calculations, right? I'm not getting the mechanical load calculation and then rerunning it myself at the office. I'm a plans examiner. My job is to make sure that you did a load calculation. I'm looking for certain variables. We'll talk more about that when we get into mechanical design here soon. But I look for that load calculation. I verify that the equipment has the capacity to meet the load, and then I'm done, right? That's how I verify compliance. The same thing happens when it comes to the actual installation process. I, as an inspector, am there to make sure it's installed properly. It's installed safely. I'm not running around the building, the entire complex, making sure that every room gets the adequate amount of air pressure, all right? That all those systems are working together effectively. That's where we have, again, this verification, testing, commissioning process. Someone is going to, the expectation is that someone is going to verify that we're getting 430 CFMs of air in this duct at this location. Because again, the expectation is that we're going to test those systems and to make sure that we have efficient buildings that operate effectively. It's not good enough to say, hey, the heat plant in the middle of the building works well, right? It turns on. After it leaves the mechanical room, we don't know what happens to it, right? And that's where, again, we have this functional testing expectation. That's why we require identification of this process up front. What test, who's doing it, when are we doing it, right? So that we know that the proper duct distribution takes place. Because what and this is where I'm going to have this video. Tab, go ahead. You're muted if you're trying to talk. I'll give you a second and I'll keep going. If you just interrupt me whenever you get the chance. So when we think about, again, the proper distribution of these ducts, I know that the ducts are installed. I am not holding up my wind meter to say, okay, am I getting 650 CFMs out of this spot? That's my expectation of the commissioning process, right? Of the verification process. Very similar. We've got a video here doing a little bit of duct leakage. We're gonna watch the first couple, yeah, we'll watch.
Hi, in this video we're going to use a duct
Everybody hear it? Give me a thumbs up.
blower door to measure duct leakage to outside.
So just like what we did with the duct leakage test, we're measuring pressure in the house in relationship to outside the house. Before we were measuring the duct pressure inside the duct in relationship to outside the duct. So I am going to measure the house.
I didn't get any thumbs up, so I don't know if you could hear that or not. So ultimately what that video is showing in a residential context is, again, that we're pressurizing the building and then seeing by equalizing that pressure through the duct system, utilizing a secondary fan system, right? I don't know if I can jump through it. It won't let me. We're actually able, wow, what do you mean there's no thumbs up option? I'm sorry, we'll watch that again. Come on now. Now it's just mad at me.
Hi, in this video we're going to use a duct blaster and a blower door to measure duct leakage to outside.
So just like what we did with the duct leakage test, we're measuring pressure in the house in relationship to outside the house. Before we were measuring the duct pressure inside the duct in relationship to outside the duct. So I am going to measure the house pressure, which would be the input in reference to outside. So my first goes here, and then I'm going to be measuring the fan pressure in relationship to the house. And again, that fan pressure gets translated into a flow number. But we're actually, when we do the blower door test, we're going to do an automated test. So the computer will do all the measurements for us here after we've set it up properly. Before we do those tests, though, we're going to do a duct leakage to outside test. And the duct leakage to outside test needs a blower door and a duct tester running simultaneously in order to get that measurement. What we're doing is we're pressurizing the house with the blower door, and it works off the principle of you need a hole and a pressure across that hole in order for air to move through a hole. If I have a hole inside the house and I have equal pressure on either side of the hole, then air won't move through that hole. So if I have a duct leak that's inside the house, I won't be able to measure that because I pressurized the house and the duct to that 25 pascals of pressure. But if I have duct up in my attic, for example, I don't have the same pressure in the attic as I do inside the duct, so I'll be able to measure the flow of air flowing out of the duct in that unconditioned space or that outside space, that duct that's outside the building envelope. So we're going to start by pressurizing the house and covering the fan inlet to baseline. We have to baseline it, and then we'll pressurize the house, and then we'll take the measurement here.
So Robbie's talking about this in context of residential, but we can visualize a similar concept for commercial, right? We're going to pressurize the building and then identify those potential air leakage points where that duct leaves our thermal envelope, leaves our control space.
So in order to do our baseline pressure, I need to cover this inlet to separate it from the outside. And then we'll do our baseline pressure here.
So he's going to turn these on, and then
So
we'll see the shift over
this
to
is
the other
just
device.
seeing what the normal, in essence, stack effect is happening in the house over a period of about 10 seconds. So we have a stack. We don't really have much stack effect of negative 0.1. Okay, the next thing we're going to do is pressurize the house to 25 pascals. That's going to be our reference pressure in the house. And I'm going to let the fan, what's called cruise. But I need to turn on the fan. So air is now coming into the house. We're blowing up the house like a balloon in essence. And I'm going to connect the duct system to this air that's coming into the house. Okay, so we have pressurized the house using the blower door. We've opened up the fan opening of the duct tester, so air is going into the duct system and air is in the house. So if I have a hole in this piece of duct here, air would not be going across that hole because the pressure inside the duct and the pressure outside the duct are the same. So you need two things for air to move through a hole. You need the actual hole and you need a pressure difference across that hole for air to move.
And so, like, and again, it's as Robbie's explaining in the residential context, we see it in the non-residential context as well, that the pressurizing the building then allows us, if there's a hole in that ductwork inside our conditioned space, we're going to lose air that's going into a conditioned space, a conditioned design space. Now, is it going to be bad? Yes, but it's not as bad as when we see it leave that conditioned space. If it goes into that attic, it goes in that crawl space, it goes where the duct runs out through an unconditioned warehouse space. That's when we're looking for it. And in those buildings, again, we're seeing a system that's a little bit more robust than just a single blower door fan, right? But ultimately, what we're trying to do is pressurize the space so that we know how well it's working and how that system is going to operate when it comes to maintaining the temperature. This is a heated warehouse space with a loading door, right? So we're going to install a series of fans. We're pressurizing that building to make sure, one, that the envelope is properly installed, and then also the duct distribution system is properly sealed and connected. But that's not just enough to just do the mechanical. We also think about the plumbing, the surface water heating system, checking those recirculating pumps, those different water heater resets and temperatures controls. All those controls have to be part of the process, and as well as the controls we associate with the rest of the building. If we're doing a multifamily, if we're doing a hotel, right, we want to make sure that those systems are designed to where when the balcony door is left open, it deactivates that. We're not trying to heat, because what will happen is you'll have some crazy guy who brings his kids and they leave that door open on the balcony and then they go out to eat. And we don't want all of that mechanical, all that energy going into heating the space in Duluth while the air escapes out the open patio door. So we need that kind of interconnected door, a hard connection to make sure that, again, when the door's open for an extended period of time, that it shuts off the system. And again, we talk about, not just these three systems, but also our power and lighting. And that's when we get into, what are we expecting it to do? Are we looking for that reporting capabilities? We see that that's part of that verification testing expectation, is that the energy monitoring is doing what it's supposed to do, and that we're controlling, and that we're also verifying that the control elements are configured and operated properly. Remember, I told you I had a project once where it said, here's all the operations, and the very last thing was to delete all control sequences after final inspection. No, we can't have that, right? We want to make sure that everything, the controls are properly, control devices, systems are all part of that verification that we get at the end, saying how the system works. What is the expectations for these luminaires? What are the relationship between occupancy sensors, right? I'm not going to stand here and dance around to see if this light turns on, right? That's going to be something that gets to be done by someone who's not an inspector, because I don't have enough time to stand and do that kind of thing. Again, same thing with, I know we're out of town, but same thing with daylight sensing controls and different devices, pieces of equipment, whether we're talking about elevators, air curtains, vestibules, all those systems are part of the process of verifying that they work effectively, they're properly installed, and that's how we get a safe building. I know we don't have a whole lot of questions, time for questions. I do want to remind you, next week we're going to get jumping. We're going to be taking off where Hope got us with the concept of entrances, looking at plan review, expectations and inspection expectations associated with fenestration. Then we're going to get into comm check again. Do a little bit of comm check before we get into mechanical design. So if you have questions on comm check, start to add them to the survey. Send me an email. Again, remember, use your survey. Give us the information that might be helpful to you. I do want to remind you, we have the Minnesota helpline. If you have questions, if your contractors have questions, your designers have questions, feel free to use us as a resource. We can do a lot of things to support them, walk them through a comm check or answer some questions. That's what we're here to do. But if you do have specific questions, you can always send them to us at the mnecsp@shumscoda.com. That'll go to the entire team, and then that way you're not just finding out one or the other. Just get the whole team at once through that website. I appreciate you guys sticking around. I apologize I didn't have too much time for questions, but if you have questions, I'll stick online. I'll stop the recording